Alright, so in this video we're looking at expressions and formulas, specifically just evaluating algebraic expressions. And what that means is they're going to give us an expression and they're going to tell us what the variables actually equal, so we can just plug them in and then evaluate the expression. So for this first one we have n plus 8m, and remember this means multiplication, it means 8 times m, and they tell us up here to evaluate the expression when m equals 5 and n equals 7. So m equals 5, so I can rewrite this. Let's see. I'm going to try to color code it as best I can here. This will be times, and then we'll have times 5, and then n, the n in blue, it'll be 7 on the front there. Alright, so from this step forward, I'm not going to necessarily color code the rest. I'll just do it in kind of a light blue here. So remember PEMDAS when you're doing these. You can't just add 7 and 8 and then multiply by 5. PEMDAS says I have to multiply and divide before I can add and subtract. So I have to go 8 times 5, and I get my 40, and then I can add 40 and 7, and I can get 47. Alright, that was kind of weird looking for. There we go, 47. Alright, so the next one we have evaluate the expression when n equals 8. So I can see n right here. So I have the same idea. I have that, and then I'll put 8. And remember this means times here. I've got my little dot for times. So I can't do 2 times 8 first, because if I'm looking at PEMDAS, exponents come before multiplication and division. So I always go in order of operations from left to right. I always basically restart that. So I need to do the 8 squared before I can do 8 times 2. So I have 2 times 8 squared is 64, and 64 times 2, because now we can move to that section of PEMDAS, is 512. Alright, the next one, so we have evaluate the expression when x is 5 and y is 7. So now we have a fractional expression. So we have 5 times, and we'll write y in there in a minute, plus x squared over x. So we'll go with red first. So x I'm going to do in red. So that's 5 squared over 5, because it's x squared on top and then x on the bottom. We can't cancel these out. That's not how that works. You need to be able to cancel it out all the way around. We actually can. I can show you this in just a minute when I fill this in. So y is going to be 7. So we can work this out just like we would any other. We can work out the top and then go to the bottom. So we'd have 5 times 7 is 35, plus 5 squared is 25. So even though multiplication comes after parentheses, when I say you can't do the multiplication before you do the exponents, you can not necessarily do them out of order, but I can do the 5 times 7 and the 5 squared at the same time because they're being added. So they're kind of separate situations. They're not being done to each other. So with this one, it's an exponent and it's being multiplied. They're both happening to the 8. But in this case, 5 times 7 is separate from 5 squared. I'm going to add those two results. So that's why I went ahead and did them at the same time. And then over 5. So you can very well go through and reduce this if you wanted to now, or you could have reduced it ahead of time, because since there's a 5, there's technically 2 5s here, right? That's what 5 squared means. I could say 5 cancels with 5, and one of these 5 cancels with one of these 5. I need to be able to cancel a 5 with each one of those pieces in order to do that. So that would show me what's left over. But now I can also do it here, and I can say, well, 35 divided by 5 is 7. 25 divided by 5 is 5, and I can add those together. So that's 5 cancels because I divided it away. So I'd end up with 12. So I can do the same thing if I add them together, and I would get, let's see. Oh, interesting. I was just looking at my answer key and I wrote the wrong number, so I have to fix my answer key real quick. So I get 10, and then 3, 4, 5, 6. So I get 60 over 5. Well, 60 divided by 5 is also 12. So whether you reduce first and then get your answer, or you reduce at the end by dividing, you'll get the exact same answer, as long as you're reducing correctly within the problem. Here, let me scooch this guy up really quick. Oh, dang it. There we go. All right, we're going to do one last one here. So we have A equals 31 minus B minus C, and we're going to find the value of A. So now there's a big difference between the last three we just did. I have an equal sign here. This is no longer an expression. It is called an equation because it has an equal sign. So now I can actually solve for a missing variable, which is what they're asking me to do. By chance, it's A equals. So really, all I have to do is simplify this right side of the equation. So we're going to go through and we're going to plug in B, and I'll just write that down here. And then we're going to plug in C. And let's get the rest of it here. So I have A equals 31 minus. All right. So A is going to equal, that's a weird A. A is going to equal, so 31 minus 4 minus 15. So if you subtract all of these, you'll get 12. And you could combine these two. You could go 15 and 4 since they're both negatives. That's negative 19 total. And then subtract that from 31 to get 12. Or you could do it one at a time and just go 31 minus 4. And then take that result and subtract 15 from that. And you're very welcome to use algebra tiles. This one's a little bit more involved. Not involved, it's just a little bit more busy because there's a lot of them. Let's say if we had 10 tiles here, right? And then I had one more because I have 31 and I want to take away 4. The big thing I'm going to have to do is split these up. So I'd have to split them up. Let's see. Does that work out? 1, 2, 3, 4, 5, 6, 7, 8. Oh, I didn't split them up quite enough. We'll split up that one. So that should be 10. So that's 2. That's 4. That's 8. And then we'll split these one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we can do the same thing here. About half. And something like that. No, they're not perfect. They should all be exactly the same size, but for the purposes of a very quick example, this also works. So this is 31. I had 30 because 10, 20, 30, and then I have the 1 down here, and I want to take away 4 of those. So 1, 2, 3, 4, and then I want to take away another 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have this 10 and then 2 more. So it's very possible to use algebra tiles on this one, and depending on which center you're at, we definitely have those available for you. But that can be a very nice way to visualize some of these simple expressions. You can also use them for multiplication and division, but depending on how big the numbers get, it can get a little bit more tedious because you have to draw just that many more. But it is definitely an option to do a visual representation. All right, so that's evaluating algebraic expressions and solving one little equation. So I will see you in the next video. I hope that helped.